Good afternoon. I am Andrea Orlandini from the National Research Council of Italy, and with Jonathan Salvietti from Siena University. We are the moderators of this roundtable, the first plenary event of this afternoon. The title of the roundtable is From Curiosity to Application: The Funding Dilemma in Robotics, and the focus of the event is to discuss about this dilemma of looking for funds to perform research and the curiosity-driven initiatives that usually are the more interesting things to develop. But actually, there are a lot of trade-offs between these two extremes. So uh, we have the pleasure to have a series of very remarkable speakers for this roundtable. I started with a random order. Emanuela Girardi, that is the founder of Pop AI, and is also, as you may know, the president of the ADRA Association, the European Association on AI, Data and Robotics. Then Professor Loredana Zollo from Campus Biomedico University, that is also the president of the IRIM Association. Then we will have also some invited speakers to present some examples of research projects that are on one side, on the other side of these two different approaches in performing research. Manolo Garabini from Pisa University, Federica Ferraguti from the University of Modena and Reggio Emilia, and Giovanni Berselli from the University of Genoa. Then to complete the list of speakers, we have also Diego Coglitore from Agenzia per la Promozione della Ricerca Europea. This is an Italian agency to promote the EU research initiatives. Nawab Kashiri from the Leonardo Innovation Hub, Matteo Willi from Pariter Partners, and I hope I didn't forget anyone. Okay, we missed, unfortunately, Vito Cacucciolo from Politecnico di Bari, that has a personal issue and can be with us today. So I would open the event with the first presentation by Manuela Girardi that will talk about the European initiative on AI, data, and robotics. Thanks.
Okay, I get closer so you can hear me. I don't think I can stand. Okay, I will be sitting. Okay, so thank you very much. Good afternoon, everybody. I'm Manuela Girardi and I'm the president of ADRA. Today, I have these 10 minutes, so let me start also my timing. And I would like to dedicate it to talk a little bit about ADRA, what is ADRA, and most of all, what we are focusing our activity on in the past year, I would say, and also in the next year. So let me start. ADRA is the AI Data and Robotics Association. Is an association that was founded in 2021, 4 years ago, to become the private partner of the European Commission in the public-private partnership in AI, data, and robotics. The goal of ADRA was to unite these different communities of AI, data, and robotics that were working quite in silos. I mean, today is quite normal to think that they're kind of at least merging in the project. But 4 years ago, I can tell you that especially robotics and AI, I mean, were quite divided. So the idea was not only to create a single community, but really to create a single community of researcher, research institute, and industry, and also with member states, so governments across all the European member states. So it was quite challenging, but I think that at the end today we can tell that we have a quite big community, and we are facing one of the biggest European problem, which is the fragmentation among all the different ecosystem that we have also nationally, and then of course, I mean, between the member states. So we're really working to take over this sort of fragmentation. These are the mission of ADRA. The very overall huge mission of ADRA was the European sovereignty in technology and in particular in AI, data and robotics. As you all know, I mean, we were not really independent from the technological point of view today in Europe, but I think that especially when it comes to the merge of AI, data and robotics, we still have a good chance to play, I mean, maybe not a winning, but at least a leading role, especially when it comes to physical AI. So we're working towards creating this community for fostering a further independence in the technology developed in Europe according to European value. We are working with the industry to ensure to support them in increasing their competitivity. And then, of course, we're working with the research institute, and we always want to do it the European way. So to make sure that European values are respected, are aligned, are included in the development on these technologies in Europe. And we write the SRIDA, the Strategic Research, Innovation, Deployment Agenda that is used by the European Commission to define the European calls for Horizon in Digital Europe and Horizon programs. These are some of the activities that we have with Finadra. We have today 16 topic groups, so 15 plus we just added a new one, which is coming now, on defense that we launched a few weeks ago, where we had our annual forum in Stavanger in Norway. And I think that defense, we already started working in this 1 year ago, more or less. Today is, of course, a very strategic point, and this is why we decided to start this topic group. And we had a very interesting workshop. And I mean, these and also all the other topic groups, we intend them as open, so everybody can participate. So you're very welcome to join us. These are some of our members. We have almost 250 members. There are research institute, universities, industry, small, medium startups, and so on. We also start having also quite a big company like Bosch, BMW, ABB, and so on. So this is ADRA. Of course, I mean, there is much more, but you can find all the information in our website. And today I wanted to dedicate some time to the physical AI, because we really think that, I mean, this is the next big frontier of technology, and it's really the convergence of artificial intelligence and robotics. And we spent quite a lot, I mean, lots of time in the past year working first on a roadmap and then on a strategy. And now we're working with the European Commission in developing some proposal, some concrete proposal to develop physical AI in Europe. So, what is physical AI? I guess that, I mean, the audience today knows quite well what is physical AI. But I think that what is important is that, unlike the traditional robots, physical AI systems are really, I mean, the difference is that they can really perceive, they can adapt in real time, they can understand the context, they can make autonomous decision. So if you think I mean, we hear a lot talking about generative AI or agentic AI. Think about bringing this agentic AI, generative agentic AI, into the physical robots. I mean, into the robots. So giving a body to the AI that it's considered the software. I think that this can really. I was attending a workshop this morning in augmenting human capabilities. Or in the relationship between human and robots, this can really bring us to the next level. So it is very, very strategic, I think. And what is it's interesting, I think that it's a kind of a bidirectional relationship, because on one hand you have AI that can really transform a lot of robotics, but on the other hand you have robotics can bring AI to the next level of innovation, really to the next paradigm. I just make some example. For instance, AI transforming robotics, we can have a sort of enhanced perception, so the vision system with semantic understanding. Or we can have the adaptive learning, for instance, learning from the demonstration, reinforcement learning from complex motor skills, and so on. And then, of course, you have the autonomy and the decision making. When we think about robots, they can be humanoid or can be industrial robots. We really think about something that is rigid. It's maybe big most of the times, and it's not that flexible. and it has to be programmed to do a specific task in a very specific context. With AI, we really go out of this box. It can become flexible, it can become adaptable, and it can really learn real time from the context, from the real world. And then if we move to robotics driving AI innovation, this is also very important because you have this physical interaction that is really linking AI to the real world constraints. And you can really enhance the embodied reasoning, for instance, or you can have a multi-modal integration. And then you can really sort of think about deploying the different challenges. For instance, the challenges of AI today is energy efficiency, environment and unpredictability, and then of course safety and human interaction. So these are the two sides of AI improving robotics and robotics driving AI innovation. I will not stop on the market, but I mean, if we think about the robotic markets and we think about AI markets, are two huge market really, I mean, scaling up exponentially. So if you bring them together, there are few statistics at the moment. Some they say that, I mean, this is the market growth. Of course, it's growing a lot. I think it will be much more than this. This is 30 billion market by 2032. But I think that we are just at the beginning and it will be a much bigger market. So who are the leaders? I prepared this slide last week before they announced that ABB was, was bought by SoftBanks. So I was like, okay, we have Europe and Japan, but if I look at the first position, they're all Japanese, most of them Japanese, and then Chinese, and then we can move to Europe or to the States. But anyway, I think that still today, if we look at industrial robotics, we can say that Europe and Japan are the two leading players. But if we move about to physical AI, or better to humanoid robotics, this is completely different. I mean, we see that the scenario, is United States on one side and China on the other side. And I really checked lots of statistics, lots of graphics and so on, especially for the humanoid. And probably if we look at the robots, we see these were supposed to be movies, but I mean, we see lots of robots doing amazing things, jumping, assembling motors in the factories already, delivering food. The point is that most of these robots, even if they're really, they are advertised or promoted as robots with physical AI, so with embodied AI, they're not really safe according to the European rules today. So this morning I was seeing, a hand doing some task and accomplishing some task, and it seems very complicated. Then you see the video of these Chinese robots jumping, dancing, doing any kind of things, and it seems something that can be already included in the real time. But it's not the case. This is not there yet. But when we look at this video, we have the feeling that we're already much farther than what we are with innovation, and we're not today. So here we see some American robots like Figure AI, then you have the Field AI or DoorDash. They just got last week 450 million because this is the amount of money they get in the States if you just launch a startup, from scratch in physical AI. And then you have some European robots. And I think that it's important to see that all in Europe, we have an excellence in research, we have an excellence in industrial automation, in manufacturing force. So we have a great opportunity, and we have also some great startup and research center that are working in robotics. So we have really a great opportunity and we cannot miss it. So this is the most important thing. So I'm adding it to the end of my time, but I want to say a couple of things before concluding. So in other, as I mentioned, we are working on this AI power robotics or physical AI since 1 year, more or less. What we did is that we started with a different approach. Not only starting with the research, but we started running some workshop with the industry, with manufacturing industry, big European manufacturing industry, to try to understand what they needed to buy, European robotics, European solution, not to go to Chinese or American. And we understood that, at the end, regardless the sector they're working, or regardless the function that they're developing, at the end, more or less, they have the same needs. And so we were like, and most of all, they share the same challenges because they share the same technical, organizational, governance challenges. But all of them, they told us that they have three main challenges that are the learning. It is very difficult and very expensive to do the learning of a physical AI system. The safety, because the solution that they are using today with American and Chinese robot, they are not safe and they're not secure. And then the scalability. It is very difficult once they find the solution in Europe to scale it up because of the lack, we will discuss it later, the lack of capital and so on. So what we are doing since more or less 1 year, and we are taking it now to the next level, is that we identified with this. Okay, these are just sorry, just to show you. I mean, they all share the same needs, but they all share also the same barrier to adoption. So the lack of reliability, like I mentioned, inability to perform basic human tasks such inspection, dexterity, and structured task understanding, and so on. The data governance is a very big challenge. The startup that are struggling, I mentioned it with funding and continuity risk. Supply chain are not resilient. A solution like interoperability, and so on. So what did we do? We said, okay, let's do the following. If you're all sharing the same needs, I mean, if you all need a robot that is doing the picking, then it can be in automotive, in pharmaceutical, or in other sector. Let's try to find, and it's very difficult to test the capabilities of a single robot in each sector, in each vertical. Let's find a way to put these needs together and to find some solution through the value chain of the research institute or the startup and see if it's possible to develop these needs that are end user driven, to test them, to qualify them, and then to provide them to the end user so that they can use a European solution. And so we developed this concept that we called the qualification center, and we present it to the European Commission. They really like the concept, and now we are in the initial phase of developing it. So we are running this workshop again with this big, the main industry player, understanding what they need, defining some priorities. Probably we will start with the picking or another function. And from then we will we'll identify some solution. Once identified, we will test it and we will help them scaling, which is the most important thing so that they will be able to provide their solution to all the European players. This I wanted to show you because and I'm finishing because I finished my time. And I wanted to show you to show you that what ADRA is doing is not only, writing the strategic agenda or creating the ecosystem or working towards the European independence in technology, but what we're trying to do is also to find some concrete practical solutions to support the development of European solution in technology, in AI, data, and robotics, and to bring this solution to the end users, so to the industry, to make sure that they can use also European solution. Thank you.
Okay, so now we move to the second part, so to another part of this plenary, and so we invited three winner of three projects that are funded by the Fondo Italiano per la Scienza and Fondo Italiano per la Scienza Applicata. So here we will see successful examples of projects that are either let's say basic science or for applied science. So I think that while they are struggling to connect the stuff, we can start in rigorous alphabetical order. So I think that Berzelli Giovanni is the first. And so you will have the slide there. So now we will see the three presentation in a row, then we will have question for this panel, and then we will move on with the industry and with the APRE agency.
Yeah, it works. Okay. Well, first of all, thank you very much for inviting me. And yeah, this short pitch is to, let's say, present the idea under a FISA grant called Companion. The title is Compliant Components for Human-like Robotic Manipulation. And well, first of all, I would like to thank, usually you end thanking the people. I would like to start thanking the people that have been working with me in realizing this project. So all the team at the University of Genova and the Advanced Robotic Departments at the IIT. So in this project, basically, we're not just developing hands and grippers, but we're also developing design tools that help designers in conceiving new solutions. Basically, what we do in our lab is more virtual than physical. So we spend a lot of time in virtual prototyping of hands and grippers in contact with a soft world, or a hand which is soft itself. So this is basically the very first hand that I myself designed a long time ago, let's say 10 years ago, that already contains some of the design solution that we are using also today. It is tendon driven. It is, let's say, has soft covers, and differently from other solutions that you can find in the literature, very differently from other solutions that you can find in the literature, is not underactuated. So it's a hand which is highly dexterous with 25 degrees of freedom and 25 motors, which is philosophically rather different than other hands and grippers that you can find in research and the market. Designing these hands and also conceiving these hands is a complex task. And what we're trying to do is, as I said, not just building the hand itself, but also building the design tools that can be used to conceive it. So basically, we're trying to make it simpler. This is an example that I always show to students of a gripper, which is produced in a one piece only. And the sizing of this gripper is very, very sensitive to the dimensions that the designer chooses. So it can be either labeled as reliable or labeled as unreliable. It is highly dependent on the dimensions that the mechanical engineer in this case chooses. We made it by rapid prototyping, monolithic and possibly disposable. So this is a very dense slide. I understand it might be difficult to understand at a very first glance, but it contains the framework of the project. So basically, we have a framework in which we are designing these grippers and also embedding the tendon transmission by using a multi-body software, which is enhanced with the capability to simulate tendons for those of you that know what is a multi-body software. We are tackling material properties in a very, very rigorous way. So soft materials which are now modeled, not in a trivial way, but in a more sophisticated way, also embedding viscoelasticity and hyperelasticity. These are, let's say, a series of publications that are already out there where people that are not, let's say, a specific user can download open source the code that can be used to model these devices. This is more or less a timeline of our devices. Also, this I show very, very several times. Starting from the very first hand, we started to increase the level of complexity in geometry, and we designed a monolithic wrist. We designed a monolithic finger that can be conceived as reliable. We used, let's say, meta materials to add the degrees of freedom to the wrist. I will not spend any more time on this slide because time is running fast, but basically the outcome of this project would be an actuated arm with elbow, wrist, and hand, which is comprises several actuators and not just the one that are used for simple motion. Basically, one of the main goals is to reduce the cost as much as possible. So let's say this is a FISA grant, so connects research to industry. So basically, takeaway messages. We are, let's say, trying to use non-traditional design solutions, again, in new, novel concepts for hands and grippers. Not underactuated hands that can be used for prosthetics maybe are not that useful for humanoid robotics. So this was the time, the right time for getting into the market overactuated hands. Our contribution is to provide design tools which are user-friendly, so they can be used also by industry, and reliable compliant components. Okay, thank you very much for your attention. And well, if you have any question, maybe later.
We can now move to Federica Ferraguti, and she will present a FIS project, right?
Okay, so thank you very much for the invitation. and I will present the TRAMIS project, which is a FIS granted project, and it will have a duration of 3 years. That I think it is different with respect to the FISA projects. The goal Okay. Thank you. Okay. The goal of the project is to introduce into the operating room a robotic assistant in order to help the surgeon in executing the surgical task, being them minimal invasive surgery, so manual surgery or robotic assisted surgery, as in the case of the Da Vinci robotic system. So here is the idea of the project, which is trying to introduce a robotic manipulator in the room and helping the surgeon during the execution of the task. So the main modules that will be developed are, on the one side, AI-based. We need to understand what is going on into the scene, and so we will have semantic scene understanding. Then we need to develop the robotic part and have the robot moving autonomously with a safe and efficient motion planning and robot control. And then we have two other models that are the study and the assessment of the ergonomy of the main surgeon, trying to optimize the ergonomy with our robot introduction. And finally, we want to perform a performance assessment of the surgeon because we want to use the platform even in training centers. The use case is a partial nephrectomy because it is executed both manually with standard laparoscopy and even robotic assisted with the Da Vinci. The goal is to remove the tumor from the kidney and extract the tumor from the skin. The team includes 10 people at Unimore, and so at our lab, but includes even several collaborations in Italy and in Europe. On the one side, for the engineering part, we have Politecnico di Milano and Università di Chieti Pescara. For the ethical part, and so for developing the ethical framework for the overall project, we have University of Macerata. For regarding the surgical part, we have urologists from Istituto Europeo di Oncologia and Policlinico di Modena. And finally, we have included a big training center in Belgium, which is Orsi Academy, just to develop and validate the platform even for the training of surgeons. The main activities that will be developed starting from October, and so this month, are on the first part of the project, the study of the surgical workflow, because we need to synchronize to the actions of the main surgeon. And so on the left, we have the actions of the surgeon that need to be autonomously detected. And on the right, we have the assistant actions that are today executed manually, but need to be robotized thanks to the project. So the first part, or the parallel parts in this project development, are semantic scene understanding. We need to detect the organs, detect the tools into the scene, and even recognize the surgical actions and phases. On the other side, we need to develop the motion planning and robot control algorithm. We will exploit imitation learning for generalizing the nominal trajectories and having them being executed autonomously. Then we will provide assistance not only through the robot, but even through augmented reality. And in this case, we will implement some augmented reality algorithm that take into consideration the deformation of the organ and overlap the 3D model, the 3D mesh on the video, on the endoscopic video in real time. Finally, the ergonomic assessment is the goal of ergonomic assessment is to optimize the ergonomics and reduce the workload for the surgeon, which is executing the main operation. I didn't find a nice picture for the ethical part, but clearly ethics will drive the overall pipeline into the project, and so will define requirements at the beginning, and all the data set, all the data that will be exchanged will be created according to the European regulations, and will avoid bias, will provides our goal is even to provide some guidelines for researchers in the development of new solution in this field. So thank you for your attention. And I think
Now it's working even the mic. Okay, cool. Yeah, I am this guy here. Maybe not everybody knows me, so a little bit of a super quick presentation. Lately involved in some projects, even with role of responsibilities like the one in this Occam FISA grant. Well, at some point you just got older and older, and it happens. That's it. You cannot really avoid it. Disclaimer: I've been co-founder of a couple of spin-off activities, and maybe hopefully some others. Let's see. So guilty, let's say. Coming from University of Pisa, Research Center Enrico Piaggio, from being, let's say, formed by these persons here, and we are working on these kind of technologies as a group. Specifically, the outcomes that brought to the Occam projects come from Iliad, this kind of projects here. I will skip all of these things there. Just one thing, we were actually at the time studying these algorithms for controlling robots with jerk constraints. And at some point, without going into the math, this company here, Eurosoft SRL, came to University of Pisa asking for a solution for motion planning and control for CNC machines able to be compliant with jerk constraints. That was 2019, and then we started collaborating since there, and now we have this project together. So the FISA project together. A couple of details of the project. So it's 5 years, 5 million. So let's say the minimum size of this kind of projects. And we are targeting a very high TRL, something that for universities is not that conventional, let's say. What's the problem we are trying to address with this project is to having low cost production and high quality production. That's sort of holy grail in these words. Like, in this case, actually, we have a very good proxy of cost if we are talking about production. So the cycle time of machine is super good proxy of cost. So if we are actually able to minimize cycle time, we can actually say that we are minimizing the cost. How it's done now? Series of heuristics after heuristics after heuristics is done to is now in place trying solving this problem for CNC machines. And why? The reason why is that we really need to do this thing in a very, very short amount of time with a very, very low computation cost. Because of course, keeping low the cost of the machines with several errors. The approach we are pursuing in the Open project is actually trying to get rid of all of these heuristics and go straight, having a clear statement of the problem and solving the exact problem we want to solve. Not a series of fake problems just because we need to be low cost, let's say. And then optimization comes into play. Nonlinear optimization in general cannot be solved, but convex problems can actually be solved efficiently and reliably. Okay, and okay, this is well-known fact since, I don't know, decades. What's new now is that today this thing is new. So we have the computational power needed to solve these problems in real time that can be used in the machine at an acceptable cost. Okay, and this is new. And this is a sort of game changer in this field because it can actually enable to use these algorithms if we want the simplest AI algorithm that we can implement on a machine in real cases. This is an example. Actually, the very first example that we performed on a 5-axis machine, and this is a comparison here, comparative case study. Of course, we cannot say the sinner, but in this case, we compared what we can get on the same machine with a commercial control against our solution. And actually, what we got is that after 2 days of an expert fine-tuning the machine, we can get still a 30% improvement in cycle times. That's mainly it for this project. So coming again, let's say to the really like to answer to a couple of underlying questions to this thing. So like this is an applied science project, right? So market. I'm from University of Pisa, so Tuscan, Italian, and European, and if you want, worldwide market. We are applying this to some techniques, blade cutting for fuse, for wood, laser cutting, plasma cutting, and of course robotics. Just to mention, laser cutting, for example, this story is quite nice. So in Tuscany, we have one of the world leading group in laser cutting, ELEN, that actually started as a startup from University of Florence with a couple of professors. And they are now competing with other 3-4 groups from China and the US. And they alone have revenue this company of some hundreds of millions, and they can generate let's say work round in just in Tuscany of roughly 1 billion euros. Wow, I mean it seems huge. Well, said that, I think that to really compete in the game we are trying to play in today, we need a couple of orders of magnitude more in investments. I read actually a post today on LinkedIn. EU is preparing a 1 billion act in AI, sort of fund planning. So maybe someone here can confirm or not what I'm saying. And in the post they were saying, okay guys, so EU is trying to compete with 1 billion in a trillion game. So if we are looking like at these things like a sort of poker game, we cannot really even buy the fish to sit at the table. That's from my side. Mike. No,
So okay, so now we have okay, after what Manolo said, we want to extend the question to our panelists. So the question is, what does funding dilemma in robotics means in your experience? Now, so this idea of searching money for basic science or for applied science. So, I mean, we can start maybe with Federica, as I know that she prepared the question in the presentation.
Okay. In my case, the main problem is how to write the proposal. And in particular, in the surgical robotics field, it's the most difficult part is probably the impact part, since it's quite easy to find the social impact for a surgical robotics project, since the potential benefits for the patients and the potential advantages for the healthcare system are quite evident. The most difficult part is demonstrate that the economic impact is also relevant, because as you probably know, the cost when we need to develop a surgical robotic system of any kind are very high and can be huge. And in this sense, trying to find a balance between high social impact but even demonstrate the economic advantage for of our system is always difficult. And so uh, I'm trying to find the best way of demonstrate the cost effectiveness superiority of our projects in this field.
Well, I didn't prepare an answer, but I can give I can give a personal experience. Let's say the project that was funded to me is a FISA 2023 project. I applied also for FISA 2022 with very similar, with a very similar idea. And one of the things that was highlighted was that the market analysis was missing. So, which I added in the FISA 2023 project proposal, and that was maybe the winning part when it came to applied research. If I go directly to the specific subject that I'm dealing with, I think that in my presentation, the keyword user-friendly is something that is connected to the industrial exploitation of something which is difficult to design. So we spend a lot of time in trying to not just to solve the problem, but also to make it usable for non-experts, which goes into every single tools that we will produce within the FISA grant, but also in other research activity within the lab. So yeah, in my opinion, these two things are what differentiates, let's say, a FISA proposal from an ERC proposal. So the market analysis maybe and a direct path from lab to market, which I mean, from a researcher, maybe it's not something trivial. For me, it wasn't trivial to do market analysis. I learned after this proposal, basically.
Come here.
Let's say more than what I said super quickly, not to waste additional time. I think again that the real main issue that we have in Europe today is the um, lack of a proper amount of funding. This has been somehow highlighted in the first Draghi report 1 year and something ago, and again in the last couple of speeches that Mario held in the last couple of months, one in Rimini and the other in the Commission. He told that very little has been done in let's say the line he wrote down in his report, quantifying in a fork between 11 and 30%. And second point, so we have to, if we want to hurry up, according to him. Second point, the amount of money considered in this plan that was 800 billions has to be increased. So these are his words, let's say.
So Now, to be even more happy, we can see some numbers from Professor Zollo. Yeah, and then this part will introduce the second part where we will talk also with people coming from industry and from agencies. And so, please, Loredana.
Thank you, Jonathan. My speech will be very brief, but basically has two main aims. The first one is to clarify the terms we're using today, because I was very interested in the terms used for the name of the roundtable, curiosity driven, but we have to clarify the meaning of that. And I would also share with you some numbers regarding the funding programs in Europe and in the other world. First of all, be curious, because it is proven by the studies in neurophysiology that curiosity plays a fundamental role for learning and memory. So this is the basis. The neural mechanisms are not well known, but we know that curiosity can help living better and in good condition for learning and memory. And the second a message is what is the difference between curiosity-driven science and mission-directed research? Looking in the literature as a researcher, I have found a very interesting papers recently published on PNAS that try to address this difference. And you can see here the definition of curiosity-driven science and mission-directed research, but the key message is that when we are looking for curiosity-driven science, we are considering research where the scientists can choose the idea, the direction of the research. So the distinction is basically based on who selects the research questions. There is not an agency, not a funding state or government and so on, but the researcher is deciding what is the direction of his or her own research. The mission-directed research is the other way around. So we have government, industry, or other agency that are deciding the strategy, the research line to follow and to fund. And when we look at the European programs, I want just to show the difference between Horizon 2020 and Horizon Europe. It is now living from 2021 up to 2027. We basically consider curiosity-driven the equivalent of basic research. It is not exactly the same, but the excellent research was in Horizon 2020 is grouped here. You can see the square in red on the left side, and we can see the ERC, the Marie Curie, and also the research infrastructure and the historical fact open project, the very high risk project that now are moved. And in Horizon Europe, we can have the same three programs, the ERC, Marie Curie Actions, and research infrastructure, but we have no the fact open anymore, but we have a new pillar that is the open innovation, where you can consider the basic research included in the AC Pathfinder. So the open innovation now is considered the pillar focused on the experimental development that can start from the very basic research in the Pathfinder and can guide the researcher up to the market with all the other programs, the transition, the accelerator, and the business program. What about the budget allocation? We have the excellent science is pillar 1, ERC, Marie Curie, research infrastructure, and the experimental development, so the EEC is pillar 3. This is the budget distribution. The total budget allocated in 7 years is 95 billion euros, more or less. For the basic research in the pillar 1, we have around 25 billions. If you want to see in percentage, we have
25-26% for fundamental research, pillar 1. Most of the percentage is for pillar 2, that is focused applied research, and 14% for experimental research, experimental development. On the right side here, you can also find the main strategic research lines that are funded by the European Commission. For sure, you can see the climate and energy program, or also the health and so on. But what is the situation, the scenario in Italy? In Italy, we have three main funding programs, the so-called PRIN, as we all know, and they typically fund collaborative research. The fees, we have already mentioned them, they can be considered similar to the ERC, and they want to focus the funding on individual excellence in research, and FISA, the Italian Applied Science Fund, that are dedicated to the enhancement of industrial research and experimental development, similar to the third pillar in Europe. And if you look to the funding all over the time, you can see here on the right side, the applied research is red, while in green you have the experimental development, and the basic research is always a flat line from 2008 up to 2019, around 5,000 million euros. The next step is what is the comparison with the global competitors. If we consider again Horizon Europe, as I mentioned before, we have 95.5 billion euros for 7 years. This means that if we consider just 1 year for applied research, that is the lower TRL, we have only 3.6 billion euros. And the European funding is basically evenly distributed among all the organization types: higher education, research and development institution, and also private entities. If we compare with the United States, just in 1 year, the United States consider about $45 billion, maybe more or less the same in euros, for 1 year for basic research. There is at least an order of magnitude of difference, and also consider that most of the research is focused on the experimental development. Also, a huge difference with respect to Europe is the funding agencies, because in Europe, more than 90% of the funding comes from the government, from the state. Instead, in US, most of the funding comes from the agency, NASA or NSF for basic research, NASA for space and aeronautics, Department of Energy, and so on. In China, the situation is similar to the United States. This means that most of the attention is on the later stages of innovation, but we have different funding programs for research and development institution with respect to the higher education. This slide is regards the R&D funding for R&D institution, and we can see for the basic research funding around 80 billion RMB, that is the Chinese coin. This corresponds to around 11 billion euros per year. Anyway, this is just a small percentage of the whole funding, where the huge part is again for experimental development in green. When we focus on the funding for the higher education institutes, we have an important part of funding from the government, but 1/3, 36% of the funding comes from the private companies. This means that there is a huge attention to the applied research, especially because of the investment from the private companies. For the basic research, this time, we can have around approximately 16 billion euros per year for the higher education institution. So, in conclusion, just to start with the discussion, for sure, Europe, US, and China have each developed robust research and innovation policies, and they also compete to be the leader in innovation worldwide. However, we have lessons to learn from global competitors. First of all, US and China invest massive scale, larger funds on research with respect to Europe. And for example, in China, you have a huge partnership in between public and private to invest from fundamental research up to the experimental development in with a huge amount of funding. There is a dedicated funding for blue sky research with specific agencies that are all devoted to that. For example, NSF in US. We have large-scale programs, mission-driven, with specific mission-oriented programs for research lines that start rapidly from fundamental research into applied technology with industrial scale-up. And most important is the partnership between public and private and the ecosystem building all around the research that allows sustainability over time with long-term funding for research, a flexible execution. Before the researcher here pointed out a very important point, that is how the basic research is assessed. It is not possible to measure and provide all require every time the business model and the market analysis also for fundamental research. So maybe the modality for assessing the different projects at different year levels should be different. And I stop here.
Thanks.
The presentation of the data.
Okay, trying to remove the feeling of changing my job, but anyway, let's try to involve in the discussion also some different perspective, because so far we focus mainly on the research side, more on the academic side, I would say. And so I would have a couple of questions for Diego Coglitore, Navab Kashiri, and Matteo Elli. I hope we may have some more time and delaying a little bit the workshop. I don't know whether it is possible. Okay, some minutes. I would start in particular with Navab Kashiri to ask, because so far we have a look. We had a look of the, let's say, more the public situation in Europe, and Loredana provided us with a more general picture. So I would ask, as a representative of a company that is working in this field in research, but also in innovation, which is his feeling in how to fund the activity of research oriented to innovation, and which is also the feeling about the emerging fields that may be a potential opportunity for merging research and technological advancements.
Okay. So basically, I don't know if you hear me. Perfect. So the fact is that working on let's say on a side that is a combination of development and also the research, we let's say also being a part of a company, we need to consider, let's say, different aspects. And the fundamental one is also that how the company would benefit from that. So of course we have, for any, I would say, line of activity that we start and we open, the first thing we need to consider is what's the final outcome. So I mean, I understand the discussion on the impact on the economical side is also important also for us when we want to start something, not to have exactly a business model of let's say the advantages and the benefits at the end of the activity for the company, but to have a perspective, to have an idea of where it it may or it will have the effect directly. So I mean, we consider activities also in different, I would say, TRL levels. So we have some research that we start in collaboration with universities. I mean, we have also Giovanni and also the others we are collaborating with. We consider activities at, I would say, relatively low TRLs. I am not talking about TRL 1 or 2, which is, I mean, being in a company is not of exactly our interest specifically, but even TRL 3, 4 is something that we, let's say, allocate some interest and, of course, some investment. And we have, of course, some other activities for which it is fundamental for us to go for higher TRLs. And the way that we approach also, let's say, different activities depending on the importance of the activity and also the TRL is different. If it's something that we consider it, let's say, as a potential field of interest, as something that may be eventually beneficial for us, we also try to basically to have a co-financing for this kind of activity so that we can also be a bit more ambitious, more research oriented, and to approach, let's say, this research field in this way. Instead, if we are talking about something that we believe that it can be also more strategic for us, it's something more fundamental for us directly, it will be something that we start collaboration with university in, let's say, for higher TRLs, but also with, let's say, financing directly from us without any, because also we consider, let's say, the long-term aspect of this, uh, I would say, know-how and IP and other discussions on that, that is fundamental for us.
Okay, let me get this point to ask to Diego.
Matteo.
The In this respect, we also say that, of course, the European Commission has a twofold objective. So to foster research, and so the advancement of scientific uh, knowledge, and on the other side also is often in different schema, in different ways, for an economic impact. And so, starting from the thoughts just presented by Nawab, uh, the Commission can improve in the next program that is going to start in the following years, can find or adjust maybe some tools apart increasing the number of millions, may have some ways for foster in a more strong way this collaboration between research and technology and the company work.
So I think they are trying to. They are. Can you hear me? Yeah.
Yeah.
Okay. So they are trying to do something like that, trying to change something, but it's complex. I think like there are. I took some note like from the previous speakers, and I'm not a guy from the commission. I'm just like a national contact point. So we are a private association. We work strictly with the Ministry of University and Research, but like in a private way. We do not get funded by the ministry. And of course we work also with the commission, so we have a strict relation, of course, because our role is to help applicants to get funded if possible, especially like the Italian applicants from my side. So it's difficult to say what the next framework program will be, because there are not so many information. So there are still the commission is still dealing a lot with the member states. Some of them are pushing for something, some other for other things. The main message they want to give is that there will be a simplification of the process, and there will be more connection between basic research and more advanced applied research. So I want to start like with some note I took, just try to answer quickly. So one of the first speakers said like when answering to the funding dilemma question, writing is difficult. So actually I agree. And if you look like to the European Commission, if you apply for a collaborative project in Pillar 2, so I'm a Cluster 4 national contact point, I know how is the template. It takes you 6 months to do like a good proposal. And you can even start like 1 year before, thinking like to the consortium, to the idea behind the topic, etc. So it's difficult, and I think the message I got from the commission is that they are going to change it, hopefully like in a more simplified way, that can take like less time to the applicants to do a proposal. Otherwise, I mean, you don't have time. Many times you need a consultant for, especially like to write like market analysis, the impact part, which is difficult, is very important because it's 5 points out of 15. So it's a lot. And so let's hope they will simplify this problem. Talking about the linking between basic research, curiosity driven, and market, more research more close to the market. I think by now in Horizon Europe you already have an effort in this sense, because you have like, if you remember the slide Loredana presented, you go from the basic research pillar 1 to applied research pillar 2. So let's say you go from TRL 2 free to the close to the market. And then you have other tools like the Digital Euro program. If you are talking about AI, robotics, you have also for some other thing connecting European facilities, the Innovation Fund. But of course, it's difficult to get funding, and it's difficult to go from low TRL with your project to high TRL. So they are working on it. To get like to have more link between the project when get funded like from low TRL to high TRL. So we will see what will happen in the next 2 years, because we still have 2 years of Horizon Europe. Then we will have FP10, that probably the name will be again Horizon Europe, not much fantasy. But anyway, this is the situation. There is a lack of funding now in some area. We know it. There is already some attempt to improve the situation, especially in AI, robotics, and data. We have now the RAISE pilot that are like called dedicated to AI and robotics. There was like a communication a few days ago, like the draft of these calls are already out. If you need something, just send me an email. I will provide you the draft. And so there are more money, not enough to compete with China and US. And there are gaps, we know, investment gaps, structural gaps. The Commission is doing something for sure. We have now the AI gigafactories, we have the AI factory, we have a new AI factory in Bologna, close to the high performance center, computing center, Leonardo. And probably we will have a gigafactory in few years. So something is happening. It's still not enough. They know the problem. They know we have to be quick, because China and US are very quick. One of the problem is Europe. In Europe, some like according to what the innovators and the researcher usually say is that we have too much regulation. Sometimes it's a constraint, but it's something that we need anyway. But also in that sense, I think there will be changes.
Okay, thanks. And mm, I'm really sorry for leaving him as the last one, but I will try to make also another round for them. Matteo Elli, since we were now discussing about the lack of funds, but I would say that also it's not only the lack of funds, but maybe the lack of investments, because it's not only on the public side, the problem maybe in Italy. In Europe, there are different situations, maybe in different countries. In US, in China, they are investing a lot in technology because they, let's say, assume to have a very strong return of investment. So I would say from your perspective, the perspective of your investing company, do you see that in robotics, in this field, there can be a sort of turning point, or we will still go in, let's say, isolated experiences, but not something that is changing the game?
Yeah, sure. So thanks for having me here, and hi everyone. Are you tired? Probably yes. So we can talk 3 hours about this topic, but I try to take just or less than 10 minutes, I hope. So actually, Pariter and the RoboIT, that is the tech transfer hub that we created with the CDP Venture Capital, with the support of Leonardo and HIRIM and other research centers, born 3 years ago in order to support researchers and research in getting capital. So there is plenty of capital with regards to public money. So mm, it's a matter to dedicate more than 1 year to prepare the application, and then of course the competition is pretty high. So I have the opportunity to see several projects, and actually in other parts of Europe and the world, they are focused on the real innovation. So it means innovation that will come to the market within 5-7 years, and so that will be ready at the end of the research. So after 2 or 3 years for private investments. No, so we created, for example, RoboT in order to fill this kind of gap between the public capital and private one. And after 3 years, actually we invest more than 2 years and a half. We invested more than 20 millions in more than 30 projects. So we have created 25 companies, and we support more than 15 POCs projects, and half of them become companies after 1 or less than 1 year. And we analyze more than 500 projects. So it means that it's not a matter of scientific production or quality. It's a matter to be ready for the market. So I listened to one of the comments was about your proposal, your project was that you had to improve the review or the financial review, and that's the key point. So if you have a good technology, it doesn't mean that for the investor or financial investor, it's a good investment. So, for example, investor, and this is not a good thing, but it's like that. They don't care about the impact of the technology of the performance of the technology. It's a matter of getting capital, more capital than the capital that we invested in the company. And in order to support a project that can have an impact or create good technologies, there is institutionals and public investment. For example, in RoboIT, we have institutional investors like CDP Venture Capital that is fundamental to support super early stage investment opportunity, because the risk is super high, so there are no private investor getting that risk. So we need institutional investors. But currently, we have a lack of capital, private one, in the second or third stage of investments. So we have a lot of capital for research, institutional or public capital to support research. Then we get onto the stage supporting as a RoboIT researcher, Italian researchers and scientists. Just to give you some numbers, we on pre-seed, on early stage or pre-company investment, we made 80% of the market. So it means that basically we have the opportunity, and we are lucky to see all the pre-seed opportunities, and we support most of them, basically all the market. And but we are struggling to get more capital on the second phase, so where the company should grow and should bring on board salespeople, create their sales team, etc. So in Italy, we have not so much capital with regards to this stage. So we need to grow abroad, and probably within I can't disclose today, but within 1-2 weeks, so probably you will see some news about foreign capital invested in Italian companies, or let's say embody AI Italian project supported by foreign capital. So the point is not the quality; it's to get closer to the market, not focus on the perfect. If you would like to be entrepreneurs or create new companies, is not just focus on the performance of the quality of technologies, but create the technology or let's say, adapt your technology in order to be ready for the market and fill the gap of the market. What the market need, what the investors would like to support are projects and companies that can change, not dramatically, but even can make a very small improvement into the market. So actually, there is plenty of capital on the pre-seed, early stage investment. We are lacking capital on the next stage.
Okay, so thanks a lot. Would propose anyone with an idea to contact him.
Yeah,
And
sure.
all,
And tomorrow we will present Rob IT before the.
yeah, and then I keep the opportunity to ask another thing, and then move to back to Diego and Nawab. From your perspective, if you would put in order, whatever, two fields in which you see that there is this opportunity, even though, let's say, that not taking care of quality is not usually the scientific approach, but if you can suggest some area when you see that there are a lot of possibility and potentials.
Yeah, sure. So actually, of course, the future is robotic, no? So we are living in an exciting but scary moment. So basically, the main technology we are looking for and we are analyzing are related to humanoid robots, LIM, large language model, or enabling technologies that can support this shift from automation to cognitive robotics. So basically, all the technology that can support sensors, software, AI agents, etc., that can support this shift. And the application related to swarm robotics, interaction between human and robots. So actually, in 3-5 years, probably we will be at a turning point where we will have how to replicate AI. So the world will change, and probably in 3-5 years we will be out of the loop within some of those applications. And so you have to be ready, make your choice, and be ready for the change.
Okay, thanks a lot. And to Diego, then I would ask, because actually also in this Horizon Europe program, there is now a lot of attention in generative AI applied often, not always, but often in robotics. This is a trend that would be reinforced and further extended. And I have some idea, but do you have some feeling about whether this initial investment is giving the expect is actually getting the expected impact, or there are some open challenges that are still on the table? Michael.
I think there are still a lot of open challenges, open question, of course. We know like there were topic on generative AI for robotics. I think Emanuela can answer better than me to this question. What will happen, like if we look like to the policy framework, like which is something that like even you like as a researcher should look to understand a little bit the trend of the technology, more than the trends because you know them, the orientation of the European Commission, and like try to align your research to this orientation. So to, I mean, increase your percentage of success in a proposal. I think robotics will still play like a big role together with AI, of course. I think they will go like in a parallel path together towards the next framework program. So we know like always look into those three pillars. If we look like to the new framework program, at least like to the new framework of the competitiveness fund, the ones, let's say, that comes from the Draghi suggestion. So now we have four policy windows. They are called like this. So we have one dedicated, let's say, to industry and defense. Another one is dedicated to the digital leadership. So, and there are a lot of money there, a lot of opportunities for everything is about AI, data, and robotics.
Thanks. Last question for Nawab. To apologize, I will make an hard question. In Europe, we have the AI Act, and now also in Italy, since very few days, we have also a national law on AI that is sort of complementary with the AI Act. In other countries like US and China, they don't have strong regulation like in the Europe, and maybe Europe is on this side is on the upfront is advancing maybe some problems that other countries maybe are not considering. So from the company point of view, from Leonardo point of view, is this perceived as many people said as a barrier to develop new technology, new solutions, and then open, for instance, new markets, or is something that is felt like something that is necessary to be sure that we are developing things on the right path, on the safe path? Which is your feeling about this? And also, of course, always in connection also with robotics, that is an embedded physical AI in this sense.
Yeah, the point is that also I can say that within the company we have I would say very strict regulation for what concerns let's say the implementation or the use or the application of artificial intelligence in a way that let's say we are within the let's say the moral the boundaries. So I wouldn't see it exactly like a barrier. Of course, like any other regulation, it requires complying with uh, let's say with caution and understanding of the capabilities of this new technology. But yeah, I mean, to give a short answer, I don't believe it is, at least from our perspective, it is a barrier.
Okay, thanks a lot. So I believe that we are out of time. I would thank all the speakers for contributing in this roundtable. I hope that the attendees have something valuable to keep at home. I would thank also the project's presenters. I would thank also Jonathan. I would ask you to join me on the stage. And then thanks a lot. And the workshop are going to start, so I believe that you have to move on the other rooms. Yeah.
Yeah, sorry, a very brief logistic information. The workshop are starting now. We shifted 15 minutes the duration of the workshop, so also the robo pitch will be shifted by 15 minutes. If some of you has a presentation during the pitch, you plus the poster after the 90 minutes of the workshop, please go to the room to upload the presentation now, and then also please go to the Sala Caravaggio to append the poster. Thank you very much.
Don't run on the stage.